idea the new intention.
Left the meeting in that night.
Which meeting?
Oh, Akunji and on this.
Left tire.
Everyone left the meeting in the.
Everyone. Yes, madam. The meeting will right left tire. Meeting unnadi on unnadi. ಅವರ ಜಾಯಿನ್ ಅಂಡ್ ಬುಕ್ ಫಿರ ನಮ್ಮ ಜಾಯಿನ್ ಮನ್ಪಡುದು ಜಕ್ ಜಾಯಿನ್ ಆಗ್ತಾರೆ
It start ಮಾಡ್ಕೊಂಡದಮ್ಮ
ಯೂಟ್ಯೂಬ್ ಮಾತ್ರ ಒಂದು ಸೈಡ್ ಕಟ್ ಹಾಕೊಂಡು ಸ್ಕ್ರೀನ್ ವಿಂಡೋ ಫುಲ್ ಸ್ಕ್ರೀನ್ ಬರ್ತನೆ ಬರ್ಕೊಂಡು
ಇಂಚಿಗೆ ಬೇತಂದ ಫುಲ್ ಗೇರ್ ಹಾಕಿ
నేను ఫుల్ స్క్రీన్ ಮಾಡ್ಬಿಡ ಕಂಟ್ರೋಲ್ ಮಾಡ್ತಾರೆ ಫುಲ್ ಆಡ ಬರ್ಕೊಂಡು ಬುಕ್ ಆರ್ಪಿ ಪಾತ್ರ ನಮ್ಮ ಫುಲ್ ದಿಕ್ಕ ಎತ್ತೆ ಬರ್ಕೊಂಡು ಎತ್ತೆ ಬರ್ಕೊಂಡು
ಇದು ಶಿಕ್ಷಕ ಬರ್ತದೆ.
ವಿಂಡೋದಿಂದ
ಅಲ್ಲ ಏನಿಲ್ಲ, ಸ್ಟಾರ್ಟ್ ಮಾಡೋದಾ ಈಗ? 5 minutes ವೇಟ್ ಮಾಡೋಣ. ಇನ್ನೊಂದು 5 minutes. ಮತ್ತೆ 20 ಜನ ಆಡ ಅಲ್ಲ 5 minutes ಸ್ಟಾರ್ಟ್ ಮಾಡುವ. ಮತ್ತೆ ಅವರು
ಬೊಕ್ಕ ಜಾಯಿನ್ ಆವಲಿ
ಜಾಯಿನ್ ಆವಡ
ಇಂಟ್ರೊಡಕ್ಷನ್. ಮಂತೊಂದೆ ಅವಳೆದ್ದು ಮಾತ್ರ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀನಿ.
Esteemed faculty, honored guests, research scholars, fellow classmates, and participants from various institutes, a very good afternoon to one and all. I, Vaishnavi Pai, student of 2nd MSc Analytical Chemistry, would like to welcome you all to the national level webinar on climate change research in India, efforts and outcomes by Dr. Chaitanya D, Scientist SF, National Atmospheric Research Laboratory, NARL, Department of Space, Government of India, Gadaki, Tirupati District, Andhra Pradesh, India. Prayer is an action. It is a process of talking to God with energy to achieve purpose. So let us begin this program by seeking blessings of God.
Bless the Lord, oh my soul, oh my soul, I worship His holy name. Sing like never before, oh my soul, I worship Your holy name. The the sun comes up, it's a new day drawing. It's time to sing his song again. Whatever may pass and whatever lies before me, let me be singing till the evening comes. Bless the Lord, oh my soul, oh my soul. I worship His holy name. Sing like never before, oh my soul. I worship Your holy name. You're rich and loud, and you're slow to anger. Your name is great, and Your heart is kind. For all Your goodness, I will keep on singing. 10,000 reasons for my heart to find. Bless the Lord, oh my soul, oh my soul. I worship His holy name. Sing like never before, oh my soul. I worship Your holy name. And on that day when my strength is failing, the end was near and my time has come, still my soul will sing Your praise unending. 10,000 years and then forevermore. Bless the Lord, oh my soul, oh my soul. I worship His holy name. Sing like never before, oh my soul. I worship Your holy name. Bless the Lord, oh my soul, oh my soul. I worship His holy name. Sing like never before, oh my soul. I worship Your holy name. Yes, I will worship Your holy name. Lord, I worship Your holy name.
Ever since its inception, the Department of Postgraduate Studies and Research in Chemistry has been pioneer in organizing several research-related webinars, guest talks, and endowment lectures to make the students gain insights on current research trends. We believe in the power of knowledge sharing, collaboration, and continuous learning. Let us have a look at various activities conducted by the Department of Postgraduate Studies and Research in Chemistry.
St. Aloysius College Autonomous, Mangaluru belongs to a network of educational institutions administered by the Society of Jesus, a religious order which runs schools, colleges, universities in more than 105 countries in the world. Established on the historical Edhia Hill in the coastal city of Mangalore in 1880, St. Aloysius College prides itself in its heritage of 143 years. Thousands of students who have passed the portals of this institution have rendered outstanding service to humankind not only in India but across the globe. The college was conferred with autonomous status in the year 2007. It has also been accredited for the fourth cycle with A++ grade and recognized by UGC as a college with potential for excellence. The college has been upgraded to star status by the Department of Biotechnology, New Delhi. The college, along with UG and PG courses, also offers PhD and postdoctoral programs under Mangalore University. Department of Chemistry aims to transform chemistry education with the curriculum driven by global competencies for grooming young minds into talented and motivated scientific professionals with human values and concern for the environment. The Department of Chemistry, being one of the oldest departments of the college, offers studies in chemistry for both UG and PG students. MSc Analytical Chemistry was started in the year 2007 as an excellent academic and placement record with proud alumni all over India and abroad. MSc Chemistry started on 2012, has established itself as another feather in the cap of the college. The PG department has been approved as research center affiliated to Mangalore University. 6 faculty members from the department are approved as research guides under the Mangalore University. The Scientific Research and Innovation Wing of our college is equipped with advanced instruments for analysis and characterization. The Advanced Instrumentation Center has the facilities like infrared spectrometer, surface area analyzer, multi-lamp photocatalytic reactor, gas chromatography, X-ray diffractometer, thermogravimetric analyzer, electrochemical workstation and UV spectrometer. With these instruments, various organic and inorganic compounds as well as reaction methodologies can be tested and analyzed with greater accuracy and are useful in research projects. Research is an integral part of the postgraduate curriculum. Students are encouraged to engage themselves in the active research during their academic tenure. The department has signed MOUs with various research institutes like PPISR, Bengaluru, through which students are provided with intensive week-long research trainings. The department provides coaching for NET and SLET for all the PG students cracking these examinations. The department also offers certificate courses with a view to provide access to the best quality learning resources. Salient features of these courses include best-in-class instructors, weekly assignments ensuring student progress in timely manner, and systematic approach enabling towards desired learning objectives. The department has excellent campus placement record. Reputed companies such as Apotex India Limited, Synergene International, Biocon, Sequence Scientific, BASF India Private Limited, Cipla, AstraZeneca have visited college for campus placements. Every year, the placement wing of the college provides the training to all students to equip the students with the necessary skills. The department has taken many initiatives to enable students acquire knowledge by interaction with eminent speakers through international and national guest seminars and webinars, guest lectures, and alumni interactions. Every year, the Subject Association of the department organizes Analyst, a national-level intercollegiate fest to promote chemistry among undergraduate and postgraduate students. Various competitions are held during the event and students from various UG and PG colleges actively take part in this event every year. The department heartily welcomes you for this one-day national-level seminar on advances in chemical research. Let the young minds unite for a better tomorrow.
I now request coordinator of today's program, Dr. Divya Shetty, to welcome the gathering and introduce today's resource person.
Very good afternoon, one and all. First of all, it is with great pleasure I extend hearty welcome to the resource person of today's national level webinar on climate change research in India, efforts and outcomes. Dr. Chaitanya Jain, an excellent researcher, a class topper, a Marie Curie fellow, presently working as scientist in Atmospheric Research Laboratory, Department of Space under Government of India in Andhra Pradesh. Chaitanya D. Jain hails from Sagara Taluk, Shimoga district, Karnataka, and completed primary and higher secondary education in his village. He obtained his bachelor's degree in science from SDM College, Ujre, Dakshina Kannada, and master's degree from Mangalore University. He then briefly worked as a junior research scientist at Syngenta Biosciences Private Limited, Goa. While working in Goa, he got the Madam Marie Curie Early Stage Training Fellowship from the University of Science and Technology, Lille, France, to conduct his doctoral research in atmospheric laboratory. He obtained his PhD in 2011 under the supervision of Dr. Krista Fishin. He then moved to CNRS ICARE Laboratory in Orleans, France for his postdoctoral research for 3 years and joined National Atmospheric Research Laboratory, Department of Space, Government of India, Tirupati, Andhra Pradesh as a scientist in 2014. Since joining NAR, he has been involved in setting up the Atmospheric Chemistry Research Facility at Atmospheric Research Laboratory. His main research interests are atmospheric measurements, trace and greenhouse gases, VOCs, aerosol chemical characterization, at a tropical rural site and a new instrument development for measuring chemical species that are important in atmospheric science research. He is also responsible for ISRO GBP project management at NAR. He has been awarded with Mangalore University Chemistry Teachers Association Award for his outstanding performance in bachelor's degree and 2 gold medals in MSc Chemistry. He has more than 25 research publications in peer-reviewed international journals and 2 book chapters to his credit. Once again, hearty welcome Dr. Chaitanya. It is with great pleasure I extend warm welcome to the president of today's program, Dr. Ronald Nazare, in his absence. It is with great pleasure I extend warm welcome to our head of the department, Dr. Zina Rodriguez. I would like to extend a warm welcome to the delegates joining in large numbers from all over India for this training research. It is with great pleasure I welcome all my dear faculties and students for this webinar. Also, I heartily welcome Mr. Praveen sir and his technical team to this program. Thank you once again.
Thank you, ma'am, and welcome to you too. I now request HOD of Postgraduate Studies and Research in Chemistry, Dr. Vinola Rodriguez, to address the gathering.
Respected dignitaries of the days, resource person for the webinar, Dr. Chaitanya D, scientist at National Atmospheric Research Laboratory, Department of Space, Andhra Pradesh, coordinated for the program, Dr. Divya N. Shetty, delegates participating online from various parts of the country, dear faculty members from the chemistry department and from other departments of our college, and my dearest student participants. A warm and a hearty welcome to you. St. Aloysius College is a 143-year-old Jesuit institution and has been at the forefront of the academic excellence for several years, committed in shaping young minds, fostering a culture of research and innovation, and creating future leaders in various disciplines. The postgraduate Department of Chemistry is an integral part of our institution and holds a prominent place among the academic units. The postgraduate Department of Chemistry offers 2 programs, MSc Chemistry and MSc Analytical Chemistry, and is also a center for research consisting of PhD supervisors and students working for their PhD degree. The department fosters the growth and development of the students and faculties through various programs such as FDPs, conferences, seminars, and webinars. This webinar on climate change research in India, efforts and outcomes, organized by the PG Department of Studies and Research in Chemistry at St. Aloysius College, aims to serve as a platform for professionals and students to network with peers and experts in the field, potentially leading to future career opportunities or collaborations. It also fosters knowledge about the latest developments, research findings, and innovations in the field of chemistry. This helps to keep students, faculties, and researchers updated with the latest trends and breakthroughs. Let us use this program as a platform to broaden our horizons, challenge our perspectives, and emerge as better educators and researchers. Once again, a warm welcome to each one participating in this webinar. Thank you.
Thank you, ma'am. With great pleasure, I would now request Dr. Chaitanya D, Scientist, SF, National Atmospheric Research Laboratory, to take over.
Thank you. The president of the function, HOD, and the coordinator. Am I audible? Sorry. Am I audible?
Yes, sir. Audible, sir.
Yeah, okay. Thank you. Thank you very much for this opportunity, first of all. And then thank you to the organizers making me look younger in the poster, which was like 12 years old photo of mine, and most of you might not have recognized me. So I'm the same person, a little bit old now. So thank you for this opportunity, definitely. And then I understand the, all the audience here soon after the lunch, sitting in this seminar for 1 hour. Bit tough, but I'll make sure that, you will not get that bored. So I'll try to share my screen first. Is it visible? Hello?
Yes, it is visible.
No, sir.
Now?
Yes, sir. Now it is visible.
Okay. Okay, so the title of this talk, what I have given is Climate Change Research in India, Efforts and Outcomes. I think many of you or most of you know the issue of climate change and then why we need to be worried about it. What I thought is, every one of us, we hear these climate change issue and all these things, but many times what happens is we miss the intrinsic link it has with other things like, human life and our food scarcity, social well-being. So many things are associated with this climate change issue. And then this is a research area which combines many interdisciplinary subjects like physics, chemistry, meteorology, dynamics, and then emissions, modeling. So many things are involved in this. It's a very, very complex subject. So what I thought, giving an overview of climate change research, and then its initiative, especially over India, and the outcomes what we are seeing for last many years, like 2 decades or so. I thought of giving that, and then that's why I gave the title as Climate Change Research in India, Efforts and Outcomes. In this talk, what I will do is, before going into the focused work on India, I would like to give, keeping in the mind that there are a lot of MSc students, the postgraduate students here, which would be helpful for them to shape their career if they really want to come into this field of climate change research. So it would be helpful for them if I give some general introduction about the climate change, what is happening, why is it serious, And then what are the global efforts in mitigating the climate change issue?
Yeah.
And then how do we go ahead with the climate change research approach? And then what are the efforts in India? And then from my institute, that is NARL, National Atmospheric Research Laboratory, we are also involved in climate change research since 2016 onwards. If and then what are our efforts in that? And finally, I'll try to summarize. And then I hope to finish this presentation in around 1 hour and 1 hour 10 minutes or so. Hopefully I'll be able to finish it. And then if I'm exceeding the time, I would request coordinator to stop me. And then so that I'll try to finish it off in time. Okay.
Sir, sorry to interrupt you.
So coming to the climate change problem and why is it serious? Before going to the topic of why is it serious, how do you define the climate change? Climate change is change in the statistical distribution of the weather patterns when that change lasts for an extended period of time, few decades to centuries. If you are changing the weather patterns, if you are seeing the weather pattern changes over a long period of time, that can be termed as climate change. And this is a very, very simplified definition in a layman language so that everybody can follow this, okay? However, when this climate change topic comes into picture, people often get confused with air pollution. Okay, they are closely linked, but not the same. On the other hand, air pollution is the introduction of harmful material, mostly concerning the health, to the atmosphere, causing damage to the living organism and to the environment. Okay, so there is a striking difference between climate change and air pollution, but they are very, very closely linked. So I just wanted to make it clear, climate change and air pollution, when people talk about climate change, it's a different topic. And when they talk about the air pollution, that's a different topic. There is a close interlink between them.
Sir,
How
sorry
do we say? Is that okay?
Sorry to interrupt you, sir. Am I audible?
Hello?
Sir, could you please share the screen? I mean, go to the presenter mode.
Yeah, the slides are not changing.
It's changing, but font is less. Small font is small.
That's full screen only, normally. Just a second, I'll call my technician, otherwise, just 1 second.
Now it's fine.
Now is it okay?
Yes.
Some background noise is there. I'm sorry. Hello? Just 1 second, I'll call my technician.
Somebody is joined. Kottaraj. His name is Kottaraj.
Unmuted. This is a problem. This one.
Yeah, Google Meet. Even I don't know to operate also.
Echo,
Zoom,
echo,
okay, we can understand.
echo.
He's doing the person from others.
Yeah. It is in read mode also. It is okay.
He's presenting.
Yeah, it's not audible.
Not present.
If he made in read mode or zoom and
Yeah, that is presenter mode. Next
oh,
step you can see.
third one is there. Last one.
Yeah, that only you should present. Or in the when he presents, no, right click he can do. You can click on and show and then go to this one.
Oh, yeah.
No.
Who is that? It's loud. You tell now it is
Okay. Now
okay.
it is okay. Sir, currently it is fine. Sir, currently it is fine. You can continue.
Okay, na? Sorry, is it okay now?
Yes, sir, it is fine. You can present.
Okay, sorry for this technical issue.
Yes.
So yeah, as I was telling, it is closely interlinked. We can say that the Greek god Janus. You may be knowing this already. So he's considered as the god of beginnings, which looks into the recent past, which is nothing but our air pollution, which is a short-term problem, which is mainly focused on the health impacts. And then it also looks into the future, which is a long-term problem, which can be termed as the climate change issue. Okay, so there is striking difference. Now we will see there is climate change conferences happen every year, organized by the UN Climate Change Commission. And then recently in the Glasgow in 2021, they released a video for the awareness of the climate change issue. I would like to play that video so that it is self-explanatory, so that we all will understand what is the seriousness of climate change issue.
What we talked about? This one. That one.
Okay, not that. This one.
That is one exception.
Presentation.
You okay? You need a minute? Cool. Listen up, people. I know a thing or two about extinction. Let me tell you. I don't think this would be obvious. Going extinct is a bad thing. You're driving yourselves extinct? In 70 million years, that's the most ridiculous thing I've ever heard. At least we had an asteroid. What's your excuse? You're headed for a climate disaster, and yet every year governments spend hundreds of billions of public funds on fossil fuel subsidies. Imagine if we had spent hundreds of billions per year subsidizing giant meteors. That's what you're doing right now. Think of all the other things you can do with that money. Around the world, people are living in poverty. Don't you think helping them would make more sense than, I don't know, paying for the demise of your entire species? Let me be real for a second. You've got a huge opportunity right now. As you rebuild your economies and bounce back from this pandemic, this is humanity's big chance. So here's my wild idea. Don't choose extinction. Save your species before it's too late. Stop for you humans to stop making excuses and start making changes. Thank you.
It was self-explanatory. We need to think about how to revert this climate change issue. So just to generalize the things here, we can see the climate change problem. Why is it so serious? There are consequences like melting of the ices, changing the rain patterns, raising the sea level, damaged corals, and heat waves, cold waves. So there are a lot of things which are linked with the climate change issue, which will trouble the life of any living organisms on this earth. Now coming to the loss of life induced by the climate change, there is an estimation of approximately 5.1 million excess deaths per year are associated with the non-optimal temperatures. That means maybe higher than the normal or the colder than the normal. So because of that, almost like 5.1 million excess deaths, which is almost close to 60 to 70% of the deaths happened because of the COVID-19. Every year we are losing so many lives because of the climate change. And then this right side graph here, which depicts, you can see that per year, some areas like India, for example, we are seeing almost like close to 15,000 deaths in a year because of the temperature differences, temperature extremes, heat or cold extremes. Okay, so it's a serious business. So we are losing the human life, which is more important than any other things. And also, in recent times in India, we are seeing a lot of floods, like, so we have already seen the reports on that, like climate change impacts impacts the monsoon flooding in India, or from drought to floods, the cost of climate change for India continues to mount. So there are reports on that. And also we are seeing every day, like, every monsoon season, one or the other regions of India are getting flooded, and then a lot of life lost, a lot of properties lost is there. For example, recently it happened in the north of India. And last year, even Mangalore region, where you are from, there was a severe issue of the flooding in the monsoon. And also Kerala region, Coorg region of Karnataka. So every year we are seeing this sudden floods and excessive rainfall and changing of the rain pattern, and then a lot of heat waves. So all these issues are directly linked with the climate change issue. And also the indirect climate change impact is the deaths due to flood. Here is an estimate, statistical estimate, or the trends of the deaths due to flood. So approximately in every year we are losing more than 1,000 people because of the floods. So this is the indirect impact of the climate change. So all these things make it very, very serious that climate change has been impacting the humans, and it is going to impact the humans in future as well if we don't take any actions against it. Now the question is, where is the problem? The greenhouse gases are the real culprits of climate change. What is the global scenario? You can see post-industrial revolution, we have seen an enormous rise in all the greenhouse gases like CO2, methane, and N2O, so nitrous oxide, carbon dioxide, and methane. You can see that there is a substantial rise in CO2 concentration levels, and which is directly linked with the emissions post-industrial revolution, which are the main culprits. You can see the global carbon emitters are like, India is also picking up with them now, US, China, EU, and all other countries. So there are some marquee global emitters of the carbon. And then if you see the sector-wise, the industrial sectors, power generations, transport, land use, land cover, waste disposal and treatment, residential and commercial emissions, many different source factors are there which are emitting the greenhouse gases into the atmosphere, which is causing these issues. And then the science behind the climate change, okay, we are emitting the greenhouse gases into the atmosphere. How exactly it works, why it heats or it causes the warming, global warming issue. We will have a look into that. I think most of you know about it. It is called the greenhouse gas effect, where if you look into the Earth's energy budget, where the sun energy sun radiation reaches to the atmosphere, reaches to the surface of the Earth after absorption by the atmosphere a little bit. However, some part of it reflected back into the space from the Earth, which is called long wave radiation, what we call it as, or outgoing long wave radiation, which should escape into the space. However, because of these greenhouse gases, which interact with this outgoing IR radiation or the long wave radiation, which will trap the heat and then make the Earth surface warmer. It is like, putting a blanket on you during the cold winter night. Blanket will not have any electrical power or something which could heat you, but what it will do is it will just simply stop the radiation or heat radiation going out from your body, and it traps it so that it will make you more warmer inside the blanket. The same effect happens here on the Earth by these greenhouse gases. Okay, so different gases have different kind of greenhouse efficiency. So you can see carbon dioxide is the major thing, around 56%, and then say methane is 18%, CFC is 13%, ozone and other gases 6%. So combinedly causing the warming effect. Now there is a committee called Intergovernmental Committee for Panel for Climate Change, which releases the assessment of the climate change globally every now and then. And recent report which was published last year is called 6th Assessment Report, where they have clearly mentioned what are the parameters which are driving the climate change. For example, if you see, this is the temperature you can see in the X scale, and then these are the contributing factors, how much they are contributing. Again, you can clearly see here the greenhouse gases like carbon dioxide, methane, nitrous oxide, and halogen gases, and all these things which are causing the warming effect. However, there are other small pollutants like the aerosols, which also play a vital role in atmospheric pollution as well as climate change. They have the negative effect, and some of the aerosols like comprising the black carbon, for example, like soot kind of aerosols, which also cause the warming effect. So the net result is the warming, global warming, because if it is cooling effect, then we would have seen the cooling effect, not the warming effect. So the net effect of all these things is always the warming. That is why we are seeing the rise in the temperatures. Okay, and then the efficiency of these greenhouse gases is estimated in a term called global warming potential, where CO2, because of its higher concentration, is considered as the reference gas, and then it is considered as one global warming potential. In reference to that, what are the other gases like methane, nitrous oxide, fluorinated gases, and others, how much they are efficient in different time scales. For example, 20 years, 100 years, 200 years, because all these gases are very, very stable gases in the atmosphere. Once they are emitted into the atmosphere, they stay for very, very long time, and then they will cause this effect. Okay, the global warming potential is given by this formula here, where AX or A reference species is the efficiency of the radiation forcing, and then this is for the time scale, time horizon, like 20 years integrated over that, and then X is the concentration changes in the time. Okay, so by using this formula, we can calculate what is the potential of greenhouse gases in the atmosphere, and then we can estimate the climate forcing. Now coming to the differentiation between the natural and human drivers, as I mentioned, CO2 was there pre-industrial era also, and then the climate will be changing, CO2 changes will be there. However, the intervention of the human beings, which is causing all the damage. For example, here in this left side up figure, you can see that they have taken out the natural drivers, and then they have differentiated between the natural drivers and human and anthropogenic other sources. You can see that natural drivers have not changed much. They are in the same level almost till today. However, the human drivers or the anthropogenic influence on that, it has increased like anything post-industrial era. And then you can see that the temperature change is directly correlating with the human changes. And then if you compile the same thing like what I showed in the last slide, you can see that the net effect of all these things, the net effect due to human activities, is the major cause of warming, which increases the radiative forcing. Radiative forcing is the difference between the incoming solar radiation and outgoing solar radiation. If it is positive, then it is called warming, it causes warming effect. If it is negative, then it causes the cooling effect. So here it is the positive, so that is why the warming effect is there. Now coming to the how the CO2 actually acts as the greenhouse gas. If you see, water vapor is also there in the atmosphere, which is in very high concentration also. And then also water vapor is a very, very strong greenhouse gas. It also traps the heat. However, in the atmosphere, there are some areas where we call them as the water vapor windows, which will allow the heat to escape into the space through those windows. However, the presence of the CO2 shuts those windows partially. So this is how the CO2 presence in the atmosphere causes the global warming effect. And then this is the evidence for the global warming by the GHGs. This absorption spectrum here is already neutralized by the water vapor absorption. So water vapor absorption has been already removed from this, and then whatever you are seeing is the net effect of the warming by the different greenhouse gases like CO2, methane, and other CH4, N2 and all. And then here you can see that this is called the brightness temperature, which is less means more warming in the surface. You can see that methane and CO2, you can see that less brightness temperature you have seen. So that means they are the ones who are causing the climate change or the global warming. So there is a scientific evidence which says that there is a global warming issue. It is not like, somebody says that there is no climate change. It is there. Scientific evidence is also there with us. Now coming to that, where are these greenhouse gases coming from? So all this carbon cycle. Carbon is exchanged between a variety of forms, including atmospheric gases, oceanic carbonates, as organic materials and non-living things. There is a cyclic interaction between them, so it changes the form between one to other, and then it gets cycled in the system. Okay, so if you see this system, there is carbon dioxide which will be fixed by the plants, and then animals eat the plants, and then they will release the CO2. So CO2 is converted into carbohydrates, and then carbohydrates go, when they are eaten by the living organisms, the CO2 is released back into the atmosphere. Same thing, CO2 gets fixed in the ocean in the form of limestone, that bicarbonate and carbonate conversion, and then finally calcium carbonate. So these are the sources of carbon. And also the methane, normally the ruminants, the cattle feed, what we can call through their digestive system, they release a lot of methane. And then also the wetlands like paddy fields or the marshy lands, mangrove systems, they all will emit a lot of methane into the atmosphere. Again, the methane, which when it oxidizes in the atmospheric conditions, it will directly give CO2 and water vapor. So again, it is adding the carbon into the atmosphere in the indirect manner. And also, in the recent years, there are some reports which is called as the undeclared methane. Nobody wants to declare that methane from the dump yards. As our urbanization increases more and more, we are also increasing the waste from the urban areas. And then when these wastes are disposed in an unscientific manner in the dump yards, there is a lot of methane which is emitted from this. You can see that this is from a Bangladesh city, the picture, and then this is from somewhere in US. So you can see that a lot of methane emissions are there, and then satellite images further conclude that you can see that excess of methane from these dump yards. This is from Real Madrid, Spain, and then Madrid, Spain, and then this is from US again. So you can see that there is a clear picture of methane plume emissions, and then these sources are not declared by the governments yet, because it also involves the scientific management of the solid waste. So governments play a smart role here. So that's why we call this as undeclared methane in our research language. And then also you have the fossil fuel burning, so that will directly give back to the CO2. And then also the pollutions, by when we use the fossil fuels in our vehicles, we will release the CO2 into the atmosphere. As I said, CO2 is a very stable gas. Once you release one CO2 molecule into the atmosphere, it stays there for hundreds of years. And then that is the reason that we have the accumulation of CO2, or it is the steady increase of the CO2 over the last few decades. And then coming to the N2O, the major sector is the agricultural sector. Through the fertilizers and all, you get the N2O released into the atmosphere as well. Okay, so these are the sources. Now the question is whether we can predict the future of climate change. Is it possible? Unfortunately, we cannot predict, because prediction is always with the certainty. Okay, so when we predict something, there is a certainty attached into it, and then we are very sure about it, this is going to happen. For that, we need the data assimilation. We need a lot of accurate data management and accuracy in our model prediction. A lot of things are involved in it. So we cannot do in terms of climate change, because climate change is not only because of the emissions, it is also because of the strategies, policy makings, and also the behavioral aspects of the people, country, country action plans. So many things are involved in the climate change issue. So that is why we cannot accurately predict anything here. However, we can project. We can project if we take different paths where we will end up with. For example, if we are taking the path A, we may end up here. If we are taking the path B, we may end up here. If we are not taking anything, we can directly go here. So at the present scenario, these kind of projections can be made, which is exactly what they have done the Intergovernmental Panel for Climate Change Assessment Report in 6. They call it as shared socio-economic pathways. Earlier they were called as RCPs, that means representative concentration pathways. However, only the concentration of the GHGs may not fully justify this projections, because as I said, there are a lot of other behavioral issues are also there with the climate change fighting mitigation issue. So that is why they retermed them as the shared socio-economic pathways, where they have said, like, SSP1, SSP2, SSP3, SSP4, and SSP5. SSP1 is what we call it as taking the green road. That means you have very strict mitigation plans, and also we have very strict adaptation things. So that means the challenges may not be that much. We will tune ourselves into this issue without causing any trouble, but our developments, the economic developments, may hamper here. Wherever, when we go to the regional rivalry, where both are challenging, like adaptation as well as this one, we will not care about the others. We will restrict to extreme nationalistic approach. We will do whatever we want. We don't care about the others, and we don't care about the climate change. That is the approach. If you go, the problem here is any air pollution or climate change issue, it is unbound. There is no boundary for it, because you cannot control the air movement from India to any other country, or any other country to India. So that is why we have to be bound to the others. We have to think about the neighbors as well when we do something related to the climate change or the air pollution. And then there is also called middle of the road. We will give equal importance for the economic growth as well as mitigation policies. And then we will believe most of the our technologies, and then we are very confident that we will overcome this issue with our technology. So that means we may not have any challenges for our adaptation. Our lifestyle will not have to change much, but you have to change your mitigation. You have to challenge your mitigation policies a lot here. And then this one, it is like inequality. That means the rich countries can afford mitigation policies. The poor countries may have to suffer the climate change issues. So these are the different pathways they have projected. And then you see that if we don't do any, if we are taking this, fossil fuel driven approach, we may end up with 5 degrees more. Well, if we take the other one, regional rivalry path, SSP3, we may end up with almost like 4 degree increase over the 100 years, or 2100, for example. And then if you take the SSP1 path, that is the most preferred, but it is very difficult to follow that path. We may restrict ourselves below the 2 degree change from the Industrial Revolution era. Now coming to the global actions, are we doing anything globally to mitigate the climate change? Yes, of course, United Nations climate change framework is there. And then you might have heard Conference of Parties, COP. Recently it happened in Egypt. 2 years back it was in Glasgow. And then you might have heard about the Paris Agreement. You might have heard about the Copenhagen Agreement. All these conferences are organized by UN Framework of Climate Change, which assesses the climate change issue, and then it advises the countries to abide with the mitigation policies, come up with their national, nationally distributed, contribution pathways, actions, mitigation policies. Everything will be agreed upon in these conferences. And then here are the highlights. For example, Copenhagen some years back. You can see 2009, where all the developing economies like China, India, everyone was included in this, climate change issue, mitigation issue. In the recent 2016, where we have seen that, in the Paris Agreement, everybody, 196 countries, they agreed to increase the global average temperature, to hold the temperature below 2 degrees, and the efforts will be made to limit the temperature below 1.5 degree. And very recent ones in Glasgow in 2020, COP26 in 2021, and 2022 Egypt to COP27. You can see that they all agreed upon we will try to limit the temperature increase by 1.5 degrees, and then we will reduce the greenhouse gas emissions. In 2027, they have planned out, given the action plans, and then how to go ahead with this by cutting almost like 45% of the emissions by 2030. All these action plans were discussed properly. And then the main thing is the carbon dioxide emissions we have to cut down. And then we have to also, if we do that, probably by 2030, if we are able to cut down almost like 50% of the carbon dioxide emissions or carbon emissions, we may achieve the 1.5 degree change by 2100. So that is thing. And then the question is why this 1.5 degree is important. You can see that if you are restricting in 2100 by 1.5 degree, you may see something like 2 months of average drought and 41% of 41% more burned area by wildfires. Wheat and rice maize soya production suffers a little bit. So already we are seeing these effects, and I think in today Karnataka there is also agitation because of the water scarcity, and then we are not near it. Still we are already seeing that scarcity. If you think of the situation, if you go 2 degree rise, 3 degree rise, 4 degree rise, what would be our situation? What would be our food security? So that is why restricting the climate change issue to 1.5 degree is very, very important. For that, we have to have the mitigation plans. Now, the commitments at COP22, 26 and 27 by India are like, India committed to achieving net zero emission. Net zero emission in the sense, how much CO2 we are emitting into the atmosphere, that much CO2 will be fixed by the photosynthesis and any other means like, ocean fixing and other land fixing. So there will be no extra CO2 added into the atmosphere anymore. So we will have always the balance, how much we are emitting, that much we are fixing also. So there will not be any extra emissions. So we have committed that we will come to that by 2070. And then also by 2030, we will cut down 50% of our CO2 emissions. And then also we will cut down the 33 to 35% of the GDP from 2005 levels to 2030. So this means if this much emissions are there, GDP will definitely suffer because it will also hamper our economic growth. And also, it has announced the green hydrogen path, and then methane emissions should be cut down. However, we have not signed that yet, but methane emissions are also to be covered. And 2027, last year in Egypt, we have given the details, where are we now, how we are doing and all. So we are on the path to achieve those goals, what we have set it in the COP26. Now coming to the climate research approach, how we do the research in climate change. So there are some terminologies which would be very useful for all of us. I thought, okay, these are the basic things we may have to know before going into the climate change research. One we normally hear is the per capita GHG emissions. That means it represents the contribution of the average citizen of each country by dividing its total emissions by its population. Okay, so that is emissions, GHG emissions by each individual, that means per person. So you will not believe me, every time when we switch on the light, every time when we switch on our car, every time when we switch on our AC, we are contributing for the emission of CO2 into the atmosphere. So we may not see that, but it is the truth. And then next is the thing called carbon footprint, which is nothing but shows how much CO2 you are emitting in a daily basis. It can be like, it can be individual, it can be a region, it can be a country, it can be globally. So how much CO2 we are emitting each day or something like that. And then there is another thing called carbon credits, which is nothing but this is like, the owner of the carbon credit is allowed to emit so much amount of the carbon dioxide into the atmosphere. If he or that organization or country exceeds that, then they have to pay hefty fees, a hefty fine to the governing bodies. So this is a new practice, and then this is also in the market, business market. That's called carbon credit. If you have excess carbon credits, you can transfer that to the country or organizations which are lacking those carbon credits. This is a reward system developed to cut down the GHG emissions. And then also we call concentrations, that is nothing but the concentration of the greenhouse gas in a certain volume of the air. That is the mixing ratio, we call it as how much CO2 is there if you take total volume of the air, something like that. And the XCO2 and XCH4, when we do the satellite measurements, they do not measure these gases directly, but they obtain the information by column average dry air mixing ratio, that means concentrations of these gases excluding the water vapor. So that is why these are denoted as XCO2 and X-methane. X represent to indicate that they are from the satellite measurements, not from the ground-based in situ measurements of these greenhouse gases. And there is also another term called net flux, which means the difference between the amount of the gas added into the atmosphere by the emissions from various sources of its emission and the amount taken up by the surface sinks, that is the fixing of the greenhouse gases, which removes the gas from the atmosphere. That net difference is called net flux, which also indicates our net emissions. Now here is an example how the satellites monitor the GHGs, XCO2 and X-methane, for example, in this. Now because measuring at the surface in very high resolution level, something like every 10 kilometers or every 20 kilometers measurement of these species, or every 100 kilometers is still a very tough task, because it involves a lot of money. It involves a lot of sophisticated instrumentation, manpower, logistics, facilities, all those things are involved. So that is why it is very difficult to put every 100 kilometers one measurement station, or every 200 kilometers one measurement station. There will be representative measurement stations across country. However, the satellites give that flexibility. They can, from the top, they can monitor whole country at a different, at a better resolution, and then we make use of these things to see how much are the concentrations of these greenhouse gases from the top. So you can see that there is a constant increase, and then this up and down here is the seasonal variability, because these emissions are also seasonally variable. So you can see that seasonal variability in each year. That is the up and down here. Now coming to the net flux, as I mentioned, the emissions of greenhouse gases are really large. That's why they are given in gigatons. For example, 1 billion metric ton is called 1 gigaton. And then they come also with large uncertainties, and it's very difficult to see that how much CO2 or any greenhouse gas is emitted from a particular source. We may estimate something, but it is very difficult to accurately estimate the emissions. That is why we normally go with the fluxes between the you're difficult to measure how much of the CO2 is or greenhouse gas is fixed and how much is emitted and what is the difference. So that is why we adopt a thing called inverse modeling. There are two types of modeling you can do. That's called, one is top-down approach, another one is bottom-up approach. Top-down approach means you have the emission values, and then using that emissions, you can computationally compute through the computational models how much CO2 should be there, the concentration of the CO2 if these are the emissions. However, that comes with the risk, as I mentioned. There are a lot of uncertainties in the CO2 emissions. So that is why we go with the other one. It is called inverse modeling, where we have the CO2 measured at the surface or by the satellites or something. Then we try to link it with the potential sinks, sources, and then their fixing mechanisms called sinks. Okay, so then if we take out this modeling activity, then eventually the difference between the sources and the sinks, we end up with emission concentrations, whatever it is. Okay, so that is why we call it as inverse modeling, where we first look into the concentrations measured at the surface or by the satellites, and then we try to link with the sources and sinks, and then we will estimate the net emissions. So the output of such inverse modeling, you can see that, the CO2, how much CO2 is emitted every year, and then what is the growth rate for each year. All these things can be done with this inverse modeling approach. So if you put it in a single frame, the climate change research components, like, we have to have the ground level measurements, meteorology, that means dynamic sources and sinks information, and then we have to have the satellite measurements to cover up the spatial distribution of these gases, and then atmospheric transport and winds and chemical transformations have to go in. If you combine everything into this computational models through the mathematical equations, we can estimate the net flux, that is the net emissions, and then that net emissions can be used to how much it will cost the climate change or the global warming. This is the approach. In this one, the in situ measurements or the measurements of the CO greenhouse gases is one of the vital inputs for this inverse modeling. So that is why people are involved in GHG measurements or the greenhouse gas measurements. How do they do that? So there is a global atmospheric watch program from World Meteorological Organization. They have set up several stations across the world where they do the GHG measurements at the surface, and they provide the data. And then these gas stations are calibrated using a central calibration laboratory, which is National Oceanographic and Atmospheric Laboratory in USA. They will release the primary standards, what they call it as calibration standards. Those standards are used to do our instrument calibration and drift, and also they can be used for secondary standard preparation and then calibrate our instruments or measurement correction time to time. And then every now and then they release the standard details, like, what is the accuracy, what is the information. The year here is 2019, X corresponds to the concentration of that standard. So we use this centralized calibration source to calibrate our measurements. Otherwise, without these calibrations, our measurements will be having no value. So we have to abide with this WMO approved calibration procedures. Now coming to the satellite missions, there are different satellites we use, like, earlier, like CMHE, NVSat, GoSat, OCO, all these satellites were there. And also there are some satellites which are lined up in future. This is just for the information purpose, I'm putting it here. So there are a lot of efforts from different space agencies like NASA, European Space Agency, ESA, Japanese Space Agency, JAXA, even India, also planning these kind of, trace gas measurements from the space. So there are different space-based measurements are coming up, and then we can always download those data sets and then apply the methods to retrieve the data of say these GHGs, and then we can see what is happening to the global carbon emissions. And then how these satellite measurements are validated. There are ground stations called Total Carbon Observing Network, like TCON. They have the FTIR instruments. They will be in the ground and then looking up in the columnar level CO2 concentrations they can get. And then these instruments are measured using the air core balloon based platforms to sample the air from ground level to almost like 25 kilometers above the ground. And then they can take the air sample and come back to the lab, and then they analyze that using GC systems or another methods like cavity ring down spectrometers. And then they use those data to validate these FTIR instruments in different places around the globe. And then these FTIR instrument measurements are used for validation of the satellite measurements, so that we will make sure that whatever we are measuring are well calibrated and quality is maintained. Now, another network is also called Network for Detection of Atmospheric Composition Change, NDACC we call it as. It is similar to that of GAW, that Global Atmospheric Watch Network. Here also we have a lot of ground stations measuring the GHGs. This is a typical greenhouse gas measurement. For example, we have all towers at level at different heights. How are the concentration changing? We can see that, and then flux measurement, we call it as what is the emission flux. That means how much emissions are happening. We can do that. We have this already said FTIR for columnar, and that means one column, atmospheric column from and ground to higher levels we can measure in one go. It's an integrated one, actually columnar integrated CO2 concentrations. And then we have also point measurements using these kind of instruments called cavity ring down spectrometers, which will directly take the sample from the outside air and then directly give you what is the concentration of CO2, methane, or other greenhouse gases. And this is a typical laboratory from, I have taken this photo from NOAA, where we have all these, CPCAR, that CRDS instrument is here, which is the point measurement. And then we have the calibration cylinders, you can see that. And then a GC system, GC also can be used to measure these concentrations. So this is a typical setup of the greenhouse gas research. And then coming to the climate change research in India, first question is it really needed? Yes, of course. The simplest answer is we are also part of the globe. So it's a global problem. We are in this globe and then we have to think about it. But if we look into the ground truth, so we see here, this is the data I have taken from this world data. It is freely available. You can always check this. We see that total GHG, even though our emissions are less compared to the other big emitters like developed economies like United States, China, Europe, and all, but still we are catching up soon. So we are as our economy developed, as India is progressing towards the development, our emissions are also increasing. So we are coming into that league. That is quite normal when we are looking into the economic growth of any country. When we have the industrialization, when we have the urbanization, definitely the emissions will increase, and then we are no different from that. But the thing is, we are also coming up almost like third highest emitters now across the globe. So that is why it is very important to monitor the GHGs over India or the climate change over India. And then the GHG measurements will definitely help in understanding the climate change monitoring over India. And then if you see the sectors, electricity and the heat are the major sector next to the agriculture, manufacturing units, transport industry, construction. So many different sources are there. They are all contributing together for this rise in GHGs. If you see the individual GHGs like CO2, you can see that we are already skyrocketing in the CO2 emissions. And then majorly because of the coal, which is the primary source of our energy. The electricity is generated by the coal thermal power plants, and then they release huge amount of CO2 when they are burnt. We cannot avoid, but it is the truth also that now we are emitting. That is why when we committed, Government of India, when we committed in the 26th COP, that conventional parties, we said, okay, we will try to reduce the coal consumption so that we can reduce the CO2 emissions as well. And then methane, same story, even though not that bad, but still agricultural sector and other waste and all, they are contributing significantly to the methane. So that's also another concern. And then the N2O, same story. So we are coming up, catching up with all the big emitters. Some of them have reversed their emissions, but we are in the rise. So that is why it is very, very important for us to monitor these emissions. And then looking into our commitments, or all the countries across the globe commitments in COP26 and 27, where they have all agreed for going to the net zero by 2070 or net zero emissions and 1.5 degree limits. And then there is a website which is funded by some of the European countries and US. It's called Carbon Action Tracker, which takes account of all the actions from different governments and planning about these emission controls and strategies to mitigate the emissions and climate change issue, how to fight it out. And then they give ratings depending on our action plans and nationally determined contributions to the climate change fight. So unfortunately, we are in the highly insufficient. That is mainly because of the limitation of the data rather than action plans, I would say. So the data is not very well out now. So we have to look into that. So for this purpose, and it is almost same for all the countries, not only for India. If any country like European sector you take, or any US you take, China you take. So the action tracker is always insufficient, it says, because we cannot meet that at the moment with the present policies. So this also underlines why we need to think about monitoring the emissions, carbon emissions from India. So if you see the journey of climate change research in India, so it all started in 1990 when the first intergovernmental panel, IPCC, was there, established, and then they started looking into the climate change scenario and assessment reports. So India contributing from that and onwards, and then later on monsoon trough boundary layer experiment, and then later Indo-X, that an Indian Ocean experiment, which, and then LASPEX, that means land surface experiment. So different experimental field campaigns, programs have been started for the climate change monitoring in India. And then into early 2000s, there are two different experiments like Arabian Sea Monsoon Experiment, ARMEX, and then TOGA, and then other, India initiated setting up an international center for climate change research in 2002. So we have taken some very good steps towards this climate change research. And late 2000s and to present, the major initiative came through this program called National Action Plan for Climate Change, NAPCC 2008. And then something like 7 different ministries were involved in it, and also Department of Space got into the action through ISRO GBP National Carbon Program, NCP, and also NIO Physical Research Laboratory, Ahmedabad Association with ISRO Australia Commonwealth Program for monitoring the emissions of the greenhouse gases over India. So as a result, this is one of the first papers in 2009. It got published using that Cabo de Rama, that is ISRO, whatever I was telling, NIO ISRO, that initiative. There was a reference station near Goa, it is called Cabo de Rama, where they have measured the CO2 and then their isotopic composition over a period of almost like 1993 to 2003. They published this paper, and then what they have said is these observations have provided critical guidance in optimizing the fluxes to constrain the regional sourcing balance, and noting that significance of estimating the flux balance in Indian subcontinent. And also they suggested in that more and more such stations should be established across country to have a good knowledge of carbon emissions or the greenhouse gas emissions. And then that was proposed and recommended. As a result, in subsequent years, we have set up several stations across country where institute like CSIR 4th Pi Institute from Bangalore, that is a CSIR institute in Bangalore, which is the pioneer, having almost like 4 different stations in Port Blair, Pondicherry, Hanley, Bangalore, and all. And then also other institute like IIT Delhi, NPL National Physical Laboratory, PRL Ahmedabad, Physical Research Laboratory Ahmedabad, Department of Space, and NERL, where we are also having 2 stations, one in Gadanki where I work, and another one in Kolkata, where we extended our greenhouse gas measurement things. And also IITM Pune, the Indian Institute of Tropical Meteorology, Pune. So they have also been actively involved in monitoring the GHGs. So this is the current scenario. And then they are all having the quality control GHG emission data, contributing to the climate change research over India. And then also there is another CO2 sensor network set up by National Remote Sensing Center, ISRO of Hyderabad, which is called a program called National Information System for Climate and Environmental Studies. That is nicest program, what we call it as. And this data is available through this website. If someone is interested, you can always go back to that and then download the data to see what is happening to our CO2. It's a CO2 sensor network is also established. That is also contributing for the CO2 monitoring across country. And then if we look into the highlights, there are several papers on GHG measurements over India or climate change research over India. So I cannot go through each and every paper of that. So that is why I have tabulated. I will just point out if someone is really interested, you can always contact me through email. I can always give the details of all these papers and then you can look into that. So you can see that, in the measurements were from Northeast region. And also they said that, the Northeast regions, mostly the CO2 and methane and other gases, they come to there through transport. So the dynamics plays an important role. And in 2015, there was a publication from CSIR 4th Pi Institute where they have added all these 4 stations like Hanle, north part of India, Andaman Nicobar, Port Blair, Puducherry near Tamil Nadu, and Bangalore. So they have established these different networks and then to study the greenhouse gas variability across the country. And then there is a temporal variation study of CO2 and CO from Ahmedabad, PRL, and then also then there is also influence of meteorology and interrelationship between the suburban regions in India by Hyderabad NRSC studies. So there are different efforts have been made for the CO2 and methane and other greenhouse gas studies. And also you can see that, the Hyderabad NRSC has a kind of TCON network, FTIR instrument. That is the first instrument in India which measures CO2, methane, CO and CO2. And then also in the very recently, the satellite measurements across India has suggested that there is a significant underestimation of the CO2 emissions reported till now. So there are more things need to be done in this. So this is the highlight. So all of them, they say that there is a circulation dynamics part which plays an important role in maintaining the budget of the Indian greenhouse gases. And then monsoon circulation also plays an important role. And also the other things like regional emissions, industrial sectors, all of them are contributing to the estimations. And then also flux measurements that gives you the net emissions. So who are the ecosystems which are fixing efficiently our greenhouse gases, that means carbon dioxide, like Kaziranga forest in the northeast India during the pre-monsoon season, which fixes the CO2 in an efficient manner. And then Haldwani and Barakot in northern India sequester maximum during the summer monsoon season. And then Betul in central India is and Sundarbans fix during the post-monsoon season. And then this winter season is normally fixed by the Pichavaram in the Puducherry and Tamil Nadu region. So these are the systems which are helping us to reduce the carbon emissions from India, where they efficiently fix the CO2 and then try to remove the CO2 burden from the atmosphere. So that is also a result of all these research work which has carried out by different people across India. And then also there were studies on how the climate change is impacting the agriculture. For example, wheat and rice, air pollution and climate change have always shown the negative impact in their yield. You can see that all are going in the negative direction, the yield, crop yields, and also globally the crop yield in terms of crop production loss in tons. You can see that in India we are for the wheat, for the soybean, maize. So everything, if you see the total crop production loss in tons, we are also there in that. India is also there. So that means climate change is also affecting our agricultural productivity. So that is also a not good sign because of our huge population. We need the food security at one point of time. And then if we are losing the crop production or the yield from the crops, what we are doing, so then we may end up with food scarcity also. So that is also important in terms of sustainability in the future. So the climate change has some impact, negative impact on that. This also is the result of the research what we have conducted. And then also it is extended using a model study. If you look into the scenarios of 2050 and 2080, India especially, we may end up with minus 30% of the crop loss. That means we may be having the crop or the we may be having the food scarcity by 30%. So that is huge. Believe me, that is not small number. That's very, very huge in terms of food security. And then another issue is the waste emissions. Waste emissions from that methane, emissions from the methane and other CO2 emissions, CO2 and other greenhouse gases from the landfill waste sites. As we go more and more urbanizing way, we are piling up more and more wastes in across the cities in India, and then they are giving rise to the huge emissions. You can see that there is a continuous rise here, for example, over Delhi. And then this is the Nature scientific reports recently published. You can see that our GDP, that means the gross domestic products, which indicates our economic growth, as it is increasing, we are also increasing the emissions from the municipal solid waste, which is again some worrisome fact that we are progressing. At the same time, we are also releasing a lot of gases which will harm our environment. And then this is the recent of studies last week only got accepted across India. The agricultural residue burning has increased by 75% from 2011. So this is really, really worrying sign. Even though we have this issue in terms of air quality over Delhi, that means the lot of agricultural crop burning is the cause for problem in air quality in Delhi during the winters. This is another aspect that where GHG emissions, greenhouse gas emissions, also increased by 75% in 12 years. So that needs to be curbed down as well. If we continue like that, then we will end up with a big trouble. Now coming to our own contribution for this GHG measurements. We started somewhere in 2016. After I joined here, we started this initiative. For those who don't know what is NARL, National Atmospheric Research Laboratory, we are the dedicated laboratory under the Department of Space for atmospheric science research. I think this is the only one institute in India which focuses on atmospheric research from surface level to 150 kilometers or more. So like ionospheric research, weather and climate, aerosols radiation, atmospheric structure and dynamics, radar application. So all these different areas of research are focused here, and I belong to this group called aerosols, radiation and trace gases, where we look into these kind of trace gas, air pollution issues and their measurements. In our group, we have all these different instruments like aerosol monitoring instruments, which give you the different parameters of aerosols, and then analytical instruments like ion chromatography, GC, and then CRDS, so spectrometers, gas chromatography, monitoring different parameters which are vital in atmospheric science, which give you the understanding of what is the problem with the composition of the atmosphere, how it is changing and how it impacts the climate change or the air quality. All these things, studies are requiring this, and also we need to monitor the incoming solar radiation. Also, there are a lot of radiation instruments are also installed, so that we have the complete package of all the gas species, aerosol species, and the incoming radiation details, so that we can get a better understanding of different processes happening in the atmosphere at the surface. And then this is our first results, what we have published in 2021, where we have done some measurements for 3 years. The highlights of that study is we have compared with the global methane and CO2 data. We have seen that the trends of their increase has been slightly higher than the global trends, which is understandable because we are in the tropical environment where our economic growth is booming, and then we are also having a lot of regional influence on our emissions. So that shows that we have the higher trends in our emissions, our concentrations, and also we have seen a strong seasonal variability, like monsoons are slightly what is that called, cleaner environment, whereas the pre-monsoon, that means the summer months, are higher with the concentration of these gases. And also we have extended recently this greenhouse gas measurement initiative to Kolkata, where we have established a an observatory called Kolkata Camp Observatory, where we have the similar setup, and then we are monitoring the greenhouse gases. And here is a simple comparison of methane and CO2 from Gadanki, where we are now, and then the Kolkata observations. You can see the urban influence directly there. Kolkata emissions are slightly higher, concentrations are slightly higher compared to the rural environment where Gadanki is situated. And then also we have attempted the inversion modeling of these methane and CO2 fluxes in collaboration with Space Physics Laboratory, another department of space laboratory situated in Trivandrum, with Dr. Sujit Kumar. So we have seen that the methane emissions are almost like 10% greater than what is already being reported. So that means we are releasing more and more methane than what we are anticipating at the moment. So those things are important when we go for the overall emission inventory preparation for the country. And the same story with the CO2. So we are like 0.9 teragram per year higher than the prior accepted fluxes or the accepted emissions what we are using now. So these are the things which gives the idea that our ground truth is being updated every time. So we are improving our understanding of this climate change scenario, so which will definitely help the policymakers to mitigate the climate change problem. Now, if I summarize these things, so if we take home whatever we have learned from today, you don't need to worry about all those graphs, all those things. These are the few points you can always take home. Like, measurements show higher seasonal amplitude. That means the summer to monsoon amplitude is higher than the global thing in India. And then there are significant enhance in GHG concentrations across Indian region and through the local and regional fluxes. And then there are still sparse GHG measurement sites, so we need more of them to have a better understanding of these things across India. And then expansion of the observational network is important, and we have to work towards that. And then we have also need to crop residue burning has become another worrisome thing for the GHG emissions, as we have seen in the recent paper. Even though government of India is having some reward systems like allowing the farmers to go for biofuel production from the residues rather than burning, but the farmers always go for the cheaper option of just burning the residuals of crops, which is worrisome, which is also air quality hazard as well as greenhouse gas emission hazard. So that we needs to be curbed down soon. And then there are like biennial reports we submitted to the United Nations. In the recent one in 2018, for example, they have said that monitoring and reporting system of GHG mitigation actions in the capacity building for India. So they have pointed out that, and then we have to work towards that, building a better efficient monitoring and reporting verification system. For that, all these research inputs will become very, very vital. And then there are challenges like as I mentioned, insufficient spatial coverage of surface measurements. We need to have the calibration. So that is also another challenging thing. We don't have the common reference stations at the moment. We are managing on our own, but the common reference station in country to calibrate all our instrument to the same standard would be definitely ideal. And then data processing that generates huge data, and that needs to be compiled together, analyzed, and then interpreted. That needs a lot of manpower, so we need to do that also. And then we need to do certain protocols for data processing. And then there is data sharing national level. We have to set up some platforms so that after a certain time of these measurements that can be released to the public portal. So those things are the challenges we are working on. Even every time when we sit in a meeting or panel discussion, these issues come up, and then we try to improve this bit by bit. We will definitely reach somewhere. Now the last question, do we stand a chance in fight against the climate change is the question we need to ask before setting up all these research and all. Definitely the model projections show that there is a light if we curb down, like all the methane, carbon dioxide, and black carbon aerosol emissions, which are absorbing time, all of them, if we curb down, we can easily restrict our global warming in to 2000 or so. However, that needs a lot of efforts from the globe as well as from individual countries. So we have to look into that. There is a limelight, we can reduce this, we can overcome this issue. However, that needs efforts, the honest and genuine efforts from the individual as well as from the countryside. And then these are some of the things. When for the CO2, we can always go for alternative fuels, operational optimization, vehicle related measures to have the better efficient vehicles, and renewal of the old vehicles. For the methanes, you can just upgrade the wastewater systems, reduce the emission from CNG vehicles, improve the agricultural practices, reduce the emissions from the mining, waste disposal. For the black carbon, we have to have different, definitely better performing domestic stoves for cooking the food, particle filters in the vehicles, and then reduce the agricultural waste and biomass burning part, manage the forest fires, efficient management of the forest fires. All these things are combined. We can always look for some reduction in the emissions. And also, as I mentioned, the aerosols also play a vital part in climate change issue. However, I have not touched this part today because this is a whole different topic, and then it needs a lot of time also. But however, there is a study by NARL again, my colleague Basha has published this work. If we have the efficient anthropogenic aerosol control also, we can contribute to the climate change issue, and then we can reduce the global warming a considerable bit. So these are the things they said, improve the infrastructure, vehicle maintenance, and then emissions we have to increase. Eventually it is all coming to the emissions. And another silver lining we have seen during the COVID-19, when all the economies, everything was closed down, many people shared the photos in their social platforms, like the Himalayas can be seen from long distance now, the pollution is not there, that, this and all. However, those are all extreme cases. We cannot run those shows on day-to-day basis because economy is also involved with those things. But it gives an indication that there is definitely a chance if we honestly and genuinely look towards reducing these emissions. And what are the government of India plans for this? For example, missions like Swachh Bharat mission, we observe every February month or something like that. So we see that always the first phase was 2014 to 2019, when the main problem was on the air quality, for example, open defecation removal and manual scavenging, awareness creation, bringing the behavioral change towards the sanitary. So it is more towards the health, whereas the phase 2 is more towards the solid waste disposal in the urban areas, which I have already mentioned, one of the major sources of greenhouse gases. Definitely these kind of action plans, if they are implemented judiciously at the ground level, definitely they are going to help us in fighting against the climate change. And then government is giving ample of financial support to Swachh Bharat mission and clean air programs in 2023 budget. You might have seen already the main things they have said is curbing down the CO2 emissions and going for the greener fuels, and also if you are doing that, and then there is a budget, so financial support from the government. Even in 2021 and 2022 also, we have had huge budget allocation for these kind of air pollution and Swachh Bharat missions, which is an encouraging sign for us. So the government is supporting, they are understanding the issue, and then they are trying to improve our emissions or reduce our emissions and improve the climate change scenario. And then also very recently, everybody heard about it, G20. So India proposed a G20 satellite for the climate observation to help countries, Global South. So our Prime Minister Shri Narendra Modi ji has already proposed this. India is coming up with an environment and climate observation satellite from the space, where we can monitor these emissions in a better way, so that it will help the policy makers. So it all depends on how we look into this issue. like personal changes are also matters here, because we have to see if there is a room which is not being used for something, and then if we are leaving the lights on there, we are contributing for the CO2 emissions. This is as simple as that. Small actions from your side, rather than going in the car. You, if you walk for 2 kilometers for something, grocery shopping or something, you are contributing for the CO2 reduction. If you are taking the public transport wherever possible, then you are contributing for the CO2 reduction rather than going in your own car. So all these small micro level behavioral changes, or our contributions also contribute to the global fight of the climate change. So I will end here. Sorry for taking you long or boring you. So I'll end with this quotation from Mahatma Gandhi ji: "The future depends on what you do today." So we all will join together to the fight of this climate change. And thank you for this opportunity.
Now the session is open for questions.
It's not stopped. Sorry. That may be crossroads. Anything close from there. In case we can get.
So there are some questions from the delegates, Dr. Chaitanya. So
Yes.
Srinath B is asking, what are the effect of climate change on health of living things? Are there any study going on?
Yeah, sure. So the main problem of climate change on our health is the extreme heat and cold waves. So I have given that in the earlier slides, the first few slides of me. So there are like something like 5.1 million deaths globally every year because of this climate change. Climate change mainly focus now goes with the temperature changes, extreme heat and extreme cold, and also the outbursts of monsoon, rain events, and all these kind of damages. Definitely, there are studies about this, and then this extreme heat and cold episodes every year, what we are seeing is having the negative impact on the health. So that is causing the deaths. So heat strokes in Andhra, for example, the place where I am now at the moment, Andhra. Here the summer is very, very harsh, goes to 45 degrees, something like that. And then we see a lot of deaths during the summer. I know those people who are working on the ground, fields and all, they get the heat strokes and then they die, unfortunately. So these issues are common, and it's the same for the other countries like West, where they face the other issues, like in the winters, the cold temperatures go to the extreme cold temperatures, and then any heating system which may not be efficient may cause damage to their health, and then they die. So that there is a correlation already with the climate change and the human health.
Yeah, there are some questions from the students, I think. So she's asking,
MS.
can I go to MSc Meteorology after BSc Biotechnology?
This I have no idea at the moment, because you please check with who are offering the meteorology course for MSc, and then you just check with them what is the basic degree they are asking for the enrollment. I have no idea, but as I mentioned, the meteorology or this kind of atmospheric science is a highly interdisciplinary subject, and then anybody can do. For example, I did my MSc in organic chemistry. I was a synthetic organic chemist, and then when I did my PhD, I went to this atmospheric chemistry. So it's a totally different, there is a lot of physics involved in it. So it is a highly interdisciplinary field, meteorology and these kind of fields. But the UGC regulations for taking the MSc meteorology students, I don't know. I don't have any idea. It is better you please check with those institutes who are offering this MSc meteorology course.
Yeah. So on behalf of our students, I wanted to ask a question. Like, by any chance, our students can approach you for the project studies or project related
Yeah.
work?
We do have project, what is that called, internship programs. Every year we take some students for their MSc projects or something like that, but they are very limited in number, so it is like first come first serve basis. Mostly the local university and then institute people will come to us. You can always send an email to our student project coordinator. There is a student project coordinator is there with your CV and the recommendation letter from your head of the department. You can always send a query. If the slots are available, they can circulate your application to all of us through online. If you go to NARL website, there is an option called student projects. You can apply through that only, and then they will circulate among all the faculty who are here, and then whoever is interested taking some of the students, they can always offer. But only thing is, here the institute is around 35 kilometers away from Tirupati city, that you please remember. And then you may have to arrange your own transport to come to Tirupati from city to the institute. That is the only thing. However, near the institute, there are some village accommodations are available, houses and rooms are available. So they can always come and then explore. So that's not a problem.
Uh, Thank you, Dr. Chaitanya. We are
Yeah.
extremely privileged to have you here as a research person. As this topic is something like climate changes is very rarely touched upon this field. So you have given sufficient insight on this. Thank you once again. Over to
Yeah,
the topic.
I also thank you for the opportunity. It was nice interacting with all of these young students here. I hope I at least a few of them, because what those who are considering the research as their career, there is a lot of potential in this field, and then there are a lot of fundings or options are also available, and there is a lot of potential in this field, the greenhouse gas and climate change research, because that is the one area which needs to be taken seriously and then worked upon. So there are a lot of available options for taking your career in this field. So please look into those things if you are really looking for the research career, rather than going in the traditional, MSc physics and then PhD in certain topics, MSc chemistry and PhD in certain topics of core science area. These are the applied areas which are really, really important for for the society, as well as they have a lot of scope also.
Thank you so much.
Yeah.
Uh, One more announcement for the participants. You can claim the certificate from the feedback form which will be sent to you.
Thank you so much, sir, for your valuable time. Your insights and perspectives on climate change has inspired many of us, and I'm sure some of us will surely explore this area in future. We also understood different steps taken towards climate change and its research globally. It was a very good overview of the current challenges and areas that need to be addressed by each individual and countries. Thank you so much, sir. It was a pleasure having you. Now I request President of today's function and Director of Loyola Center for Research and Innovation Block, Dr. Anand Nazrat, to give presidential remarks.
Thank you, Dr. Chaitanya Jain, for this wonderful presentation and the inspiring words. At the outset, I should congratulate you for moving from the traditional boundaries and from a hardcore organic chemist. You switched over from this. I'm sure the journey was very pleasant and enjoyable. I'm sure it is because of passion driven, and you are the inspiration for all these youngsters to take up these programs, take up these challenges. So going, instead of going into the traditional, there are openings available wherein they can go into if it is passion driven. And with respect to the topic by itself, majority of the time, whenever we have the programs here in the college conducting these webinars, we go for the core domains like the synthetic organic chemistry and maybe spectroscopy. Those are the ones which generally we, and we are excited to hear so many things a chemist could do. And therefore, you are the role model for us to look up to, wherein we can go ahead and have this program. And therefore, we are sincerely thankful for your effort, time in inspiring youngsters. And
Yeah,
therefore,
thank you.
which has led us also the youngsters probably to look into new avenues, sometime even to get awareness about the climate changes. And you touch upon so many things with respect to what we need to do in order. The college is also having the similar goals. In the recent past, in the Swachh Bharat Abhiyan, we were a very much active, took a very active part, and we were awarded as a clean campus, the third rank in the college category in the whole country recently. That shows the efforts and commitment by the college towards this the environment and environmental the climate changes occurring. And therefore your talk is also another awareness for us to be cautious about what we need to do and how we can be careful in the preservation of this climate, in the society, and preservation of these climate changes which occur there. We are having in the campus the social awareness. Also, we are having the awareness about the environment, environmental consciousness. So we have created Alvana here, about 1.5 acres of land inside the campus. We are having the small places wherein we are preserving every day. There is a uh, green hearts. Green hearts has been created by the students and faculty members are given a place wherein they can go and do work and contribute to the environment. And in this mission, you are all, the full session itself is an inspiration. Thank you so much for being a part of us and keep inspiring us. And we invite you come this side to our campus sometime. No doubt the traditional boundaries are broken because of this virtual, and it has its own limitations sometimes. It will be wonderful to inspire a little more when you come down to this to Bangalore and come to the college and be a part of us, inspiring more youngsters in the Vinicam campus. Thank you so much.
Thank you very much, sir. Thank you very much. Definitely, I should congratulate St. Aloysius for taking up that, tree plantation drives and all. And institutes like you, they are the core builders of the future generation. And then these things should be inculcated at the lower level. That means when they are growing up, they should be made aware of the things, consequences, what will happen if we don't care our own nature. So I would definitely appreciate your efforts towards that, and then I should congratulate all your students for being a part of this. And then I'm very sure they are all going to be responsible citizens of India, and then they will definitely care for the nature, care for the environment, and then they will be definitely cohabitating with others. So thank you very much, sir. Thank you very much for this opportunity again.
Thank you, sir. It is not joy that makes us grateful, it is gratitude that makes us joyful. Now I request Ms. Shravya, student of first MSc Chemistry, to deliver the vote of thanks.
Good evening, everyone. As we conclude this enlightening webinar on climate change research, I, Shravya, would like to take a moment to express our heartfelt appreciation to our distinguished speaker of the day, Dr. Chaitanya D., Scientist SF, National Atmospheric Research Laboratory, Department of Space, Government of India. Your presence and depth of your insights have provided valuable perspectives on pressing the issue of climate change. Thank you, sir.
Thank you.
Our sincere gratitude also goes out to Dr. Ronald Nasret, Director of LCRI Blog, for your presence and unwavering support. Thank you, sir. I extend my gratitude to Dr. Vinola Rodriguez, Head of the Department for Postgraduate Studies in Chemistry and Research, for your consistent guidance and encouragement. Thank you, ma'am. A special word of acknowledgement to Dr. Divya N. Shetty for her exceptional leadership in organizing this webinar. Your hard work and guidance have genuinely made this event possible. Thank you, ma'am. I would also like to thank Mr. Praveen from BCA department and the technical team for enabling smooth functioning of this event. Thank you.
Furthermore, I want to extend my heartfelt thanks to all the delegates across the country for participating in this webinar. Your active engagement and passion for addressing climatic change has made this event a resounding success. Thank you. Thank you everyone for joining us. Okay. Everyone can fill the feedback form. The certificates will be emailed. Thank you, sir, for joining us.
Thank you all, and have a nice day ahead, and then all the best for all the future activities and endeavors of students. Thank you joining me. Thank you.